Phew.
Welcome to a very, very special Happy Maths Hour. We are welcoming today two amazing people from Ireland and from England. We have Science Ireland, or Eoin Gill representing Maths Week Ireland, which has already passed, but Science Ireland is very much Southeast Festival Ireland, very much happening right now. And the amazing, entertaining, fascinating, scintillating, not that you're not, Eoin, Andrew Jeffrey, who, hold on, I've got to read this. Please welcome a man fluent in nearly 2 languages and whose only claim to fame is that he once held the record as the youngest person in the universe.
That's true. That is,
Well,
I swear to you, that's true.
I think that's probably true for all of us, isn't it?
Oh, rain on my parade, burst my bubble, burst my balloon. See what I did there?
But I got it. I totally got it, Andrew. Right. So welcome to both of you, and of course the wonderful Tony Bearden. Would you just like to say a couple of words about whatever you want before we finish? You'll definitely get another opportunity.
Yes.
Leave people.
Okay. Well, I'm very much involved now with working with teachers in South Africa in the poorest communities. Wonderful teachers. We do a lot of professional development. It's called AIMSEC, African Institute for Mathematical Sciences Schools Enrichment Center. I, of course, have a long history here in the UK, and setting up and running Enrich for a few years was one of the things I did. So I think we're ready to move on now.
Just very quickly, Tony, I'd like Eoin and Andrew to say just a quick something about what they're doing this week and why. Just a quick introduction. I'll do it in the reverse order. Andrew, tell us about Maths Week England.
No, good thing. Yeah, save the best to the last. Maths Week England is, I can't say this in front of Eoin, it's not fair. So it's quite a big maths festival.
The biggest in the world, I'd say.
Well, and you did say for 11 years, which is why, sorry, listeners, viewers are going, what on earth's going on? So I'm Andrew. I set up Maths Week England in 2019, and 100% of the reason I did it was because I was inspired by this man. So Eoin, for years, set up and ran Maths Week Ireland, which he'll tell you about. And I think I used his model or aspects of his model. So 100% of the credit for Maths Week England actually goes to Eoin and his partner in crime. But Maths Week England has just very simple aims. It's we did a kind of intro video which we put up this morning, which said, you know what, we believe that nobody should be hampered from following their dreams because of a lack of qualifications or understanding in mathematics. Nobody. And we believe that everybody can learn mathematics and enjoy it and get qualified in it. So we want to help people discover or rediscover or share the joy and the beauty and the structure and the patterns of maths, not just because it's lovely, but because it's about giving people cultural capital, which I guess has a lot in common with AIMSEC, actually.
Definitely.
Yeah,
we're all on the same quest. We're all doing this, all got the same goals, I think.
I think so. So that's kind of what it is.
Thank you, Andrew. Eoin, over to you. And I'm sharing the Science Week events link here as well.
Okay, that's great. Thank you, Caroline. And it's very nice to join you here. I suppose we all are doing the same thing, and for more or less the same reasons we're promoting. I suppose Maths Week is the biggest thing I'm involved in. It just happens in October, in the week containing the 16th of October. And we have Maths Week Scotland happening around this time as well. So it's great that people are bringing maths to the people, and it's very much trying to share, I suppose, an appreciation and the wonder of maths, and that's for several reasons. And one of the reasons is economic. It's access to jobs and opportunities. That's really important because a lot of the really good jobs in the world today are based on maths. But it's also just whatever job you do, maths is going to be very useful to you in your life, not just in the obvious things of your budgeting and managing your money, but a lot of mathematical thinking. The thinking that you develop with maths can help you in lots and lots of different situations in your life, particularly in problem solving. But things like things that you don't even think about, you mightn't think are maths, like planning a holiday or scheduling or even packing your bag. This is all mathematical thinking. So we think that's really important. And of course, the fact that mathematics is a language that describes how things in the real world work, things right across the universe, maths can help us understand that. So they're all different reasons. And I think it's similar to how you guys, Andrew and Caroline and Tony, are doing this as well. And as well, we love it, and we love sharing it with people, and we love the people that we meet when we're sharing it. And Andrew, I know Andrew for many years, has been coming over to Ireland for Maths Week, and Caroline has as well, and they really contribute so much to it, and bring their own unique styles. And it's all about variety, it's all about diversity, it's all about showing how many different aspects of maths there are, and sharing it with as many different people and kinds of people that we can. So I'm delighted to be here with you.
Thank you so much, both of you. And now over to Tony.
So you might wonder what sheep have to do with mathematics. Now you're going to find out. It's all about sheep talk. Now, sheep talk is bar, as you know. And what we have is just the letters B and A. So the first word only contains a single letter A. And to get the next word in each sequence, you change each A in the previous word into a B, and you change each B in the previous word into AB. So the number of A's is the number of B's in the previous word, and the number of B's is the total of the number of A's and B's in the previous word. And we start off with A, and then B, because A's turn into B's, and then B's turn into AB, and we go on from there. Now, if you've got a pencil and paper, you can write down some more words. What follows AB? Remember, the A becomes a B, and the B becomes an AB, and it's Bab. And then there's Abab, and on it goes. And the words get very long and lots of bars in them. Okay, now this is where the surprise comes in, perhaps. If we count the numbers of A's and B's, the numbers of A's are 1 in the first word, and then none, and then 1, and then 1, and then 2, and then 3, and then 5, and then 8, and so it goes on. Count the number of B's. Wow, count the number of B's. 0, and then 1B, and then 1B, and then 2 B's, and then 3 B's, and 5 B's, and then 8 B's. So what do you notice about these three sequences?
You've kind of given us a clue in the title. I heard Andrew go, so I'm going to let Andrew respond to that.
Yeah, no, this is a wonderful way of thinking about the Fibonacci sequence, invented by someone who wasn't called Fibonacci.
Absolutely.
Go on.
The nice thing about it is that it's just so beautiful the way the sequence occurs 3 times there in the numbers of A's and the numbers of B's and the number of AB's. And it's clever, isn't it?
It certainly was a surprise to me.
Okay, now this is a more familiar. The next one is a more familiar, but not quite so straightforward. But just before we do that, I think these arrows help. you see the number of A's is the numbers of B's in the previous word. And for the numbers of B's, the red arrows show you have to add up the 1 and the 2 to get the 3. And then you have to add up the 2 and the 3 to get the 5. And so you've got the idea of adding 2 terms to get the next one from the way we've constructed this. Okay. So now here we have the Fibonacci, the classic Fibonacci rabbits problem. And it's thought that Fibonacci may have brought some of these ideas about the sequence that has his name attached to it, and the golden ratio indeed, from Africa, which is fascinating. He certainly traveled in Africa and across on the Silk Road across Asia as a merchant. Now, these are very special rabbits. There's a pair of them. The newborns are put in the field at the beginning, and then they mature after a month. So they don't have any babies that first month. And then from the second month onwards, then females have a pair of babies every year. And so what we have is that there are newborn pairs of babies and baby rabbits, and then 1 year when they're just young rabbits, and then the following year they start to produce. So the question is, if we have 2 rabbits at the end of the second month, did I say years? I really should have been talking about months, and then we want to find out what happens over the year. I think I said I talked about years there, but it's actually months. Okay, so what's happening here?
Do you have any comments, Eoin, on this? Because you know what Eoin does? He takes on historic characters. He becomes the historic character. But I'm guessing it's mostly Irish people that you do that with?
Well, I have never done Fibonacci, who's Leonardo of Pisa, as he's known. I have done Leonardo da Vinci, who came somewhat later, but I think it's really important in maths to tell the stories. And
absolutely,
we don't know who first came up or who first discovered this sequence, but we do know that Fibonacci introduced it into Europe from North Africa, perhaps. But it's fascinating to know the stories of these things, and that they entertain us now, and they entertain people 800 years ago when Fibonacci wrote about them.
And I think they help to enliven the mathematics lesson. I mean, we're all involved with special weeks, and we make that a lot of fun. But lessons in school ought to be fun as well. So this summarizes, and this is exactly what Fibonacci described in his book. It was called Liber Abaci. So at the start, you've got your newborns, and after 1 month, there's a pair of young rabbits, and then after 2 months, we've still got our original pair, but they have now produced some babies. Okay, so what happens after that? Well, I think we can begin to see for the first few months what's happening here. The yellow spots are now the newborns. The pink spots are the young rabbits, and the reds are the mature rabbits who are producing babies every month. And so our original pair of rabbits is there on the left-hand column. You can see they're mature, and they are producing newborns, which are shown in yellow, every month. And then those newborns are maturing after a month, and then after the second month, they are producing babies. And so you can count the numbers there. So in how many have we got in the 5th month? If you just count them, 2, 4, 6, 8, and 13 in the 6th month. And as you see, this is the Fibonacci sequence that we saw with the sheep talk. And if you have a big piece of paper and some patience, you can carry on with this tree, this generation by generation, month by month, and see how many. There's going to be quite a lot of them at the end of a year. That's 12 months. Okay, so I like that, and it's something that we could spend quite a bit of time just working out each of these next generations.
And that's very much within the spiral learning concept, where very young learners can look at one or two or three generations, and as you get older, you can look at more generations. It's something that very young learners can get their head around, as well as older learners can get into more detail.
Now, the Fibonacci sequence has a lot of interesting properties. But there are other sequences, by the way, for you mathematicians, that share the properties of the Fibonacci sequence. But anyway, we're talking about Fibonacci today. So what we have here is the ratio of two successive terms. So we've got 1 and 1. Well, the ratio between them is 1, and then that's followed by 2. So that ratio is 2 to 1. And then it's followed by 3, and that ratio is 3 to 2. Not getting interesting until you get to 5. And then 5 to 3 is your 1.6 recurring. Now, is it very easy to set up this spreadsheet? You only need to put in the first few terms and this simple formula. A couple of simple formulas, and you've got this ratio. Well, you can produce the sequence itself with a simple formula, just adding the previous two terms and dividing each term by the previous one. You'll see it converges very quickly to 1.618 to 3 decimal places. It's down there. By the time you get to 55, it's 1.618 to 3 decimal places. And you'll see as it goes, we go down a little bit more, all the decimal places that we've worked it out here, they all agree. So it's interesting, it converges very quickly. And that is a very special number, which we'll find out. It's a very special number. And it features in architecture, in art, and we find it in nature too. So we're going to be looking at a bit of science here. So I rather like this picture, and it's quite mathematical because it's a reflection. I've sat by that waterhole for a long time, watching lots of different animals come. And I've used it to introduce elephant dreaming. Now here, this is a spiral, and it's all based on the Fibonacci sequence. It's called the golden spiral. We see that spiral, well, there's a spiral staircase there, which seems very similar, sort of spiral, and a conch shell, which has been cut open. But this is a great activity to do, drawing this elephant head and getting it out from the spiral, drawing the spiral. So how about this?
I've done the elephant on the top left, the simple one where you're being a bit creative with 5-year-olds, and it's a great little activity for 5-year-olds. It's constructed the way Tony's about to show you, but as you can see, it's literally not truncated, it's aerated. It ends at the elephant's ear, and it's a great way to introduce this concept of adding 2 and 2, and then as you'll see, and it works extremely well with young learners, and it's a great activity for all ages.
Well, I find it's quite a good idea with children to mark the square, the two squares to start with, give them squared paper, but on the squared paper to help them to mark those 2 squares where you start with the 1 and 1 for the first 2 terms. And then what we can see here is that with the 2 little squares, we add a bigger square onto it of edge 2, and then on the side another square of edge 3, and below another square of edge 5, and on the left another square of size 8, and so on. And then just a little bit of artistic license there. We can change that into the elephant's head. All those arcs are simply quarter circles, and there you have a nice spiral.
And it is a great way to practice using a compass. It's got so much power, and it can be done in a very creative way. I absolutely love this activity.
And if you haven't got a compass, you can always use a piece of string tied to your pencil and hold it down, and keep the string taut, and you can get your circle that way.
Or freehand it as well.
Oh yes, you can make a reasonable spiral there, just drawing it freehand. And it's very interesting how very often when life is starting here now, or this is all plant life, the young new growth is coiled tight, and then as it grows, these coils undo and straighten out. But there's quite a lot of pictures there of plants with a new growth in terms of a spiral, which I think are rather impressive.
I'm interested if either Eoin or Andrew have something to say about any input, any stories.
Way too much. You go first, I'll pick up the slack.
Right, Eoin.
Yeah, I think I'm happy to sit here and listen. It's really interesting.
Please do make comments whenever you feel like it.
Well, I just think it's great to go, and if people are in different parts of the world with different plant life and different, to look at what's around them and see that these patterns exist. We didn't talk about I don't know if you're going to come back to it, but patterns. Fibonacci numbers in flowers and things that.
Oh, we're coming on to that. We shall.
Well, I'll wait for that.
No, we've got some nice slides.
But it's great to look around and to investigate and look at what's around you and see where can you see patterns. I think that's really wherever you are, you'll see mathematical patterns in plants.
And we see the Fibonacci pattern in so many places once our eyes are open to it, and
And go on, Andrew. What were you? Oh, look at this! Is exactly what Eoin just said. Andrew, what stories have you got?
Well, you just preempted me there, but I do my great friend Rob Easterway and I do a podcast called Puzzling Maths. I don't think I probably need to say what that's about, but our logo is a sunflower for exactly the relationship there. I don't want to steal any thunder. Tony, are you going to talk about distances at any point?
Well, I would like you to comment on these pictures because,
Right.
I think there's a lot in this. I personally find I can see a lot of spirals, but I find it quite difficult to count these seeds or in these spirals.
I think that's a very good point. You see, we're all into maths outreach in some sense, and I have been to talks where people have simply held up a pineapple or a pine cone and gone, and can you see that there's 13 here but 21 here, and everyone's going, no, I can't. And I think we need to think very carefully because we're a few steps ahead. So when we can see that something is beautiful, I think it's beholden on us to explain why and not just say, look, I think earn the right to be heard. So, for example, you didn't just put these up. You first of all showed the construction on the previous slide. So anyone watching has some sense of, oh, okay, I see what's going on here. And I think that's a really valid point for anyone who does kind of talk about maths to people, hoping they'll be interested.
So can you talk about the distances, because it's Tony and I have not fathomed this part of it.
Yes, okay, this is incredibly fun. So it is simply a coincidence. There is no logical mathematics in this, but it is a coincidence that it just so happens the Fibonacci sequence offers us a very, very good way of converting for when Eoin and I visit each other's countries between miles and kilometers, because if I see that it is 8 miles to Dublin, then I know that it is 13 kilometers, and if it's 13 miles to Dublin, I know it's 21 kilometers, and hopefully the pubs will still be open.
Do they close the pubs in Ireland?
Yeah, no, they do. They do.
Yeah, certainly over the last 20 months, they've been closed quite a bit.
Yeah.
I would just say 8 kilometers, 20 months, by the way.
In terms of what you're showing there, I know, depending on, in a lot of parts of the world, it's very easy to find pine cones. Other parts you might have pineapples, of course, are similar. It's hard. I have sunflowers growing in my garden, but they didn't produce lovely seeds like that. I don't know if we had enough, if I had them out early enough. But pine cones are easy to find, and it's a matter. You can take a pen and just mark. They are hard to count, but we can, if you mark it. There's the spiral on it. I don't know if you can see the mark I made.
Very, very faintly. So you mark the spiral and then just count the seeds along that spiral.
Or even just, mark that one and then look at the spirals going in the opposite direction. And count those. So I'm not really doing it, demonstrating very well. But it's just you can mark them yourself and count them. It's fun to do that. You have a good picture there of it, but it's something that's handy to do, and it's quite reliable. Not all pine cones, I'm sure, are obedient, but it's very reliable. Any ones that I've found.
I think I should go out and recommend other people go out, and because there are lots of pine cones around in the UK right now. Pick one up and try it for yourself. And of course, what we've got here is not just plant life, but a mammalian fetus that is coiled when it's very tiny and new, and then uncoils gradually. So we mentioned artwork. This is one of my favorite pictures, partly because there's so much mathematics in it. It's Salvador Dali and The Last Supper, of course. And it's rather spoilt, I suppose, with the lines that we've superimposed on it there. But I wanted to do that to show how this golden rectangle, which we're introducing now, is a very special rectangle. And we did see it with the elephant dreaming, didn't we? But here we've got it with the lines, the two lines that I've got in meeting, that would be St. John, right on Christ's right-hand side there, and just below his head. So what you see on the right-hand side, there's a big square with Pentagon written across the bottom. And on the left-hand side, there's a rectangle with golden written across the bottom. And that rectangle is also the same proportions. It's got the same ratio. And the cute thing is, so when you cut off a square, you're left with another golden rectangle. And you could go on doing this forever. You can go on cutting off squares. So that's sort of the elephant dreaming process that we've just seen, but done in reverse, isn't it?
Right.
But we did start there with a rectangle that had the golden proportions. So it's golden rectangle. And I've written golden pentagon there because we've also got Salvador Dali clearly was deliberately bringing in the mathematics. with his pentagon. And yes, it's sort of three-dimensional. That window shows us a bigger pentagon with parts of 4 smaller pentagons inside it, and this bright light from the back.
Do either of you have any input on that?
So much. It's gorgeous.
Yes, go on then. Go on,
gorgeous.
say.
I just stumbled across. I wish I could say I was like cool enough to have actually planned a visit, but I once stumbled across in a town called Figueres in Spain, at the Salvador Dali hometown or museum, and it was one of the most extraordinary experiences of my life. And you realise how much he adores mathematics. I mean, that to me says a dodecahedron is being created.
Yes,
that sort of
yes.
12 beautifully perfect pentagons, and he was obsessed with this. In fact, Owen, you'll have to refresh my memory, but there was a lecture given in Maths Week Ireland a few years ago by a very famous geometer who is, am I misremembering this? Did he meet
Tom Banshoff from
Banshoff
from Brown University?
That was he, and he and I spent a very pleasant hour or two, as you should really, in a bar in a hotel with a pen and paper and pints of Guinness and a napkin, doing geometry. Well, I think I was learning geometry. He wasn't, but he was fascinating because am I right that Dali used to ask his advice on things like 3 and even 4 dimensions?
Yeah, Dali was very interested in the 4th dimension and trying to portray it. Of course, a big challenge in 3 dimensions, and he started corresponding with Tom Banshoff about this. And Tom would be a very famous higher dimensional geometer. So I'm pretty much firmly in 3 dimensions myself, but some people can think beyond that. That's the beauty of mathematics, I suppose. And yeah, Tom did talk to Dali about this, and Dali very purposely put put mathematics into his paintings. I suppose we can find the golden ratio in many other paintings, but
indeed.
Whether it's by design or by accident in cases, maybe it's hard to tell, but certainly Dali was very definite about mathematics.
Yes, this is one of the most clear-cut examples, isn't it, with his dodecagon and pentagons as well. Yes. So we're going to talk a bit about the pentagons. But first of all, let's think about working out what exactly is this golden ratio. I mean, we saw it as a ratio. I said it was the ratio between 2 successive numbers in a Fibonacci sequence, but we can see this in the geometry and solving a quadratic equation here. So the ratio of the longer to the shorter edge of the rectangle on the left there is 1/x, and for the bigger the whole rectangle you see is x plus 1/x, and that's exactly what we saw with the Salvador Dali painting. The square on the right and the rectangle on the left, and I've now just drawn it again, and this ratio is whatever x or x plus 1/1. And clearing the fractions there and solving that quadratic equation, you get x is 0.618. And then the golden ratio is the ratio of the longer to the shorter side. So it's x plus 1 or 1 plus x, which is 1.618. Well, at least it's that 2-3 decimal places. I mean, it's actually and exactly as it's given there as √5 minus 1/2. But that shows how it's worked out, and it shows exactly the same ratio as we found with the Fibonacci sequence. Bit of algebra geometry. And now Caroline, would you like to do this knot? I love the pentagonal knot.
Right.
Show us the pentagonal knot. But these
my
are
computer's operating a bit slow. Everything I'm doing is ever so slightly slow, including, I'm afraid my picture is laggy. You can hear my voice in real time, but you don't seem to be able to see me move in real time.
Here
we go.
You could make your yourself larger here if you want to.
Oh, yes, okay. Right, would you like to give me instructions, Tony?
Well, all I want you to do, Caroline, is to tie a simple knot in that piece of strip of paper that you've got.
I'm not sure it's allowing me. We haven't. Here we go. Right, a simple knot. So I'm going to tie a simple knot. It's hard because it is laggy. Okay, I'm tying a knot, cross over, follow through, and
now, Caroline, just gently ease it ever so carefully, and ease it and flatten it, and you will get a pentagon. And you can.
And here is one I made earlier.
Okay, and yes, we can see it. And of course, it's got two pieces behind that you're holding it by, but there you have a pentagon.
Yeah.
There's some activities that we'll show you in a minute, but there's some here as well that involve people maths. And one of the people maths ones is there. This is just 5 people, roughly the same size people, preferably holding out their arms and making a pentagon. Well, that's the Leonardo da Vinci's man, isn't it? With his, so this is our bodily proportions are have this golden ratio occurring in many different pairs of measurements that we might take. And yes, the pentagram on the left is fascinating. To draw from one point, if you've got 5 points on a circle, and you draw from one starting point a chord that doesn't go to the next point round, but every other point, you come back to your starting point, having made a star, not taking your pen off the paper, but you can do that on a larger scale, containing one of the smaller ones, or you can do it inside itself and then inside itself. And in the mathematical mind, you can imagine going on forever with that one.
So Owen, can I take this moment, Tony, for Owen or Andrew or both to might have something to say? You're being very good, not jumping in.
We're listening.
Not sure the rules.
Sorry, Andrew.
We're just not sure the rules.
The rules are, it's a conversation. So
say what you like. Yes, please do.
Okay. The pentagon is actually a way I advise people who are getting out of awkward social situations. Because if you're in a conversation and you find it's going nowhere, but you don't just want to say, I'm sorry, I'm just going to leave the conversation now. You just say, so tell me what's your favorite regular polygon? And they'll think that's a bit of a weird question. Or frankly, well, they're not the people I hang out with. I'm just slightly marveling at my lack of spelling ability. But did you know that the pentagon is the only shape where the number of diagonals is equal to the number of edges and the number of vertices? I did, because I don't get out a lot. It's also the only one where if you join the diagonals, the shape inside, as Tony pointed out, gives you the same shape as you had before, which I think is breathtakingly beautiful.
There's a lot in this, isn't there? Beautiful.
Do you have any input on it, Owen?
Not on that. It would have been useful to know last week for Halloween. The Vitruvian Man one, the Leonardo's famous dimensions of I think again, well, people come in all shapes and sizes, and I think maybe Leonardo's model probably fitted it very well, and maybe a lot of people do, but it's not universal.
And it's not a good idea to do it with children either, because their
No.
proportions are quite different.
Yeah, yeah, and as I say, everyone is different, and we don't quite match up to these ideal patterns anyway. But it's interesting. It is very interesting to see that those proportions do happen quite commonly in people.
Well, I think, in fact, the artist thought that the perfect person would have those dimensions, whatever perfect
Well, I
means.
don't.
I don't either.
I don't.
So here's some more people maths. I think you can see people holding each other's wrists there. There's people with their hands up in the air, making sort of pentagonal shape. You have got people doing the pentagon, 5 people each with 2 fingers, and making a star, and then having their arms around like this, making a heart, but coming together. Lovely ideas there, I think, for getting, if you've got a class of children, getting them up and getting them making pentagons in different ways. And that'll use up all that excess energy that they've got. But they'll be thinking pentagon, they'll be thinking maths. And here then, spot the patterns. We've got a flower there. And of course, got 5 petals. And if you join the tips of the petals, you have another pentagon. Of course, you've got the Dodecahedron there, and that building, that well-known building in Washington, DC, the Pentagon. Yes, and those prisms there are a line of prisms with reflections, or nice mathematical little picture there. Spot the Pentagon. And then the football, of course. You don't see as many of those footballs these days that are made with pentagons and hexagons, but it was the classic football, wasn't it? And when they were made of leather, they were usually made like that.
I think Andrew might have something to say about that. But Mr. Fullerene? No?
Beautiful, yes. I was lucky enough to, as lockdown has been sort of slowly releasing in England, one of my first things to go to was to speak to some head teachers in Cornwall at the Eden Project.
Oh, yes.
I don't know how many of you folks out there are familiar with the Eden Project. It is a very beautiful place, and it's got sort of biodomes, hemispherical biodomes, and they're made of hexagons, funnily enough, but there will always be the same number of pentagons. This is very interesting. There'll always be 12. If you take that football, there are always 12 pentagons in amongst the hexagons, however many hexagons there are. The Epcot Center in Florida at Disney is another example. And it's very simple. It's very provable with fairly basic algebra. If you just use Euler, the relationship between faces versus vertices and edges. I remember learning that about 15, 16 years ago from my friend Rob, again, who I mentioned earlier. And he very kindly sent me a sort of animation and a demonstration of why. And it's very beautiful. So I was able to say to them at the Eden Project, you know what, you are sitting on the most fantastic mathematical resource here. Let's, show your children the beauty of this.
Maybe we should supply them, or somebody should supply them at the Eden Project with a little postcard or something, which just points out the mathematics. If they look up and see this dome and says a little bit about it. Of course, they're opening another Eden Project now up in Lancashire, aren't they?
In Morecambe Bay.
Yes.
You'll have to call that East of Eden, I presume.
North. It's the North Eden Project.
I don't know.
It's not east, it's west. Well, I suppose it's east. Never mind.
I don't know whether they're going to make it with domes like the one in Cornwall. I don't know.
Yes,
they are they?
Yeah, they're going to make several habitats, and
well, that's great because it it makes it accessible to far more people now that we'll have two of them. Yeah.
But it's also a different type of vegetation. It's going to be vegetation relevant to the region.
Is it? Interesting. Not tropical.
That's my understanding. Well, there might be some tropical as well, but it's very much focused on the lakes and the Morecambe Bay, and so it's more than just it's not just a copy of the Eden Project.
But to go back to what Andrew was saying, this architects are very interested in these sorts of structures because they can make these domes, and they're very strong. They support, if they get the, got to get it right, but they are very strong and support the whole dome without a lot of cross struts having to hold it up.
I found the photograph I took.
Oh, great! Hold on. Let me see if I can make that big. Can I make Andrew big? How do I do that?
Oh yeah.
I'm going to just take everybody else out just for a moment. We'll be right back, ladies and gentlemen. Hold on.
Zoom it up a bit. There we
Remove.
go. So you can see these.
I've got to remove that. Remove that, and now it'll be. Oh, there it is. Sorry, Tony's been excluded. I can add her back.
Oh no.
Right. That's not that. We can see that, can't we now?
Yes.
So
Excellent.
Is that 12 pentagons in the hemisphere?
Yeah, you will find 12. I mean, obviously these are not perfect hemispheres because they are connected. I'm just trying to see if I can spot. I think that might be a. They have to be evenly distributed anyway. It's a really lovely. I just sort of marvel at it really as an extraordinary thing. To connect to what Tony was saying earlier. Hang on, let me get rid of this. As Tony was saying earlier, the interplay between mathematics and nature. Bees build in hexagons not because it's pretty, but because it's super efficient and strong, and the biggest area for the smallest amount of build. Which is, how do they know that? Bees never studied O-level geometry, as far as I know. And if they did, they didn't get an A. They got a B.
Well, what about pine cones? I mean,
yeah, they never went
even
to
less
school.
maths.
They never went to school.
Well, just before we leave the Buckminster, the buckyball as it's called sometimes, that shape. It was Buckminster Fuller, an architect who explored that idea and made them popular. But there's another related story or an existence that is very interesting in the 1980s. So people will probably know from their science that carbon exists in different forms. So a diamond is made of carbon.
Yes.
But so also is graphite in a pencil, and one is extremely hard and the other is extremely soft, and it's to do with how the carbon atoms lock together. And these scientists in the 1980s discovered a new form, which they called C60. They were able to determine that there was 60 atoms of carbon stuck together in some way, and they couldn't figure out for a good while how it was arranged, and they figured out eventually that it was in the exact same structure as we've seen the football or the geodesic domes, and so it's a Buckminster Fullerene carbon C60. That's only in reasonably recent times in chemistry that's been known. And the scientists involved, the chemists involved, won the Nobel Prize for their discovery. And one of them, Harry Kroto, spent a lot of time promoting science, did a lot of work around the world promoting science. And sadly, he passed away a few years ago, but he was a great science communicator.
Isn't it interesting that football designers made that design, which happens naturally in nature, and they had no idea. And they're not scientists, so it's go on. They're leather workers really, Go ahead, Tony. Sorry.
Well, I was just going to say that we could spend hours talking about tessellations and packing, the most efficient way to pack shapes together and solids, and crystallography, very important. And of course, there's a lot of group theory and mathematics in all that. That's what it's all about, really. So, yes, there's a lot we could be saying. Caroline, do you want to show this paper folding?
Yes, I'm working on getting, I've selected the correct camera, but it's not showing it. Well, I'll just show it in front of me instead. Oh, here we go. I don't know.
I think the picture, I think the slide you see there is very self-explanatory. You can take your A4 paper and you fold one corner to the opposite corner. And Caroline's doing that.
I'm hoping to do it. Here we go. So a sheet of paper and fold that corner to literally to the opposite corner, like so.
Excellent. And then you want to lay the edge, the BE edge along the edge DF, but not crease it. We just want to indicate what you see in the picture. There's a dotted line. We just want enough to be able to know where that line of symmetry will be. So BE, just match it over to DF, and okay, there you go. Now you fold both of those edges, the short pieces there on the edge. You have actually got a pentagon there, haven't you? After you've done your first fold. And the two shortest edges, which I've called BE and DF, go onto that middle line. And then you have your regular pentagon. There it is, beautiful. Well done, Caroline.
Is that regular?
Okay.
Is it actually regular though?
I don't think it is quite, but it's very nearly so. Okay, and I've used it to make a dodecahedron because it's very quick and easy to make the pieces, and you don't need to do any measuring.
It's kind of an accountant's regular pentagon then.
Very nearly, yeah.
Squeeze the edges fit.
and for older children, older students, it's actually a nice exercise to work out what the dimensions are. Yeah. And what the error is. Yeah. So here we have got a very often used bit of people maths. You get your 5 people in a pentagon equally spaced, and somebody else walks around the outside. You can imagine if it was on a piece of paper, it was a little insect crawling around the edge. And what's the total angle they turn through? Well, it's whatever your polygon, it's always going to be 360 degrees. So if you've got a regular polygon, you just divide that by the number of those angles. And here you get, for a regular pentagon, 72 degrees with 108 degrees inside. And what I've done there is just drawn our pentagon with all the angles in it, and finding those angles is a matter of knowing that it's regular, and the angles inside are 108, and using similar triangles, and you can very quickly find all the angles. So you've got some of your triangles have isosceles with 2 angles of 36 at the base, and some of them are isosceles with 2 angles of 72 at the base. So there's our pentagon divided up. And now we're not going to go into this geometry, but all of those ratios, which are marked as red to blue in length, all of those are give you the golden ratio.
Wow.
And doing that geometry is just simple school geometry, but it's rather pretty, isn't it? And now you know why Salvador Dali brought it into his painting. You know, we have a very much a golden pentagon as well as a golden rectangle.
That's beautiful. Do you know what, Tony? I laugh. That phrase, just simple school geometry. Those 4 words together, I don't know.
Well, I know what you're saying, Andrew, because when I started teaching, and, you know, for the first 20 years I was teaching, we did a fair amount of geometry. And we taught a fair amount of Euclidean geometry. And of course, in South Africa, they haven't made the same sort of changes in their curriculum. And they do a lot of Euclidean geometry as well. They don't do as much of other sorts of mathematics as the young people in the UK do, but they do a fair amount of geometry. So
it's interesting.
Yes, but it really isn't. It doesn't involve a great deal of geometry. Just a little bit of patience. It's mainly similar triangles, actually. That's all.
I think we've got 5 minutes left, so can we give Andrew and Eoin an opportunity to tell everybody about what's happening in Ireland? Oh, look at that, we've got our links. So is that it?
Well, I was just going to mention the links because, and I was going to mention a little, and I do want to hear more from Andrew and Eoin. But we've got a lot of different activities on the Aiming High website. Now, what I did when I went to South Africa in 2003, they didn't have the internet there. In most schools, very privileged schools only had the internet. And I worked in the schools in the townships, where we had we still have classes of 60, a pretty average, 80, very often 80 students in a class, and no resources except a chalkboard very often. However, now everything's changed a lot in the last 5 years because of smartphones. And most teachers now have a smartphone, not particularly because it's useful for maths, but it happens that it is. And the Aiming High website now is available to download on the app, and you can use everything offline once you've downloaded it. Now, there's all of those.
All these links are in the description. Whichever social media platform you're on, they're all in the description, so you can just click on them to get to the Aiming High website, just to let you know that. And also the links to Maths Week England and the Science Ireland that's going on at the moment, they're all there as well. Sorry, go ahead, Tony.
Well, I was just going to say that I think in some ways, COVID has brought some good changes as well as a lot of hardship and difficulties for many of us and real grief in losing people we love. But I think that for education, these online links and teaching online and sharing ideas online will continue, and using platforms like Zoom as well as this, and YouTube, of course, as well. So Caroline and I realized that a lot of children all over the world were not going to school because of COVID. So we decided that what we could do is to write inclusion and home learning guides with activities that you could start a session with, a math session at home as well as in school, where everybody could do the same activity, whether you were 4 years old or 18, and then in the same theme, suitable activities for different age groups, right through whole spanning all those ages. And we have this theory, don't we, Caroline, that we're learning from the time we open our eyes, and we're learning on this spiral, and we keep coming back to ideas as we learn, and the spiral goes up. We come back to ideas that we met earlier, and that good teaching starts to plant those seeds of ideas right in the early years and builds on them as the young people go through school. So you will see We're writing more and more of them as you know, as fast as we can. You will see these guides which build on a theme with activities for all ages. And of course, they're very useful for any lesson because in most classes, you have got quite a wide ability range, or if not, I shouldn't be saying ability, I should be saying attainment, because attainment now isn't going to be the same for all time. People who are low attainers now can be high attainers with really a lot of encouragement and believing in themselves.
And you're welcome to use these resources for Science Maths Week Ireland and Maths Week England.
Anytime, anywhere. I think, although they're designed to be for African schools, and we do a lot with making resources manipulative from junk, and that's why we call our YouTube Maths Toys, because we believe in being able to manipulate things in order to learn and do mathematical activities, and making resources from junk, because if you haven't got any money to buy resources, why not? Yeah, there's lots of things you can do.
Fantastic.
So, but now we want some.
Yes.
We want some ideas, some responses from you, and Eoin, and you, Andrew.
So, and tell us about what's going on in Ireland and the biggest. Sorry, Eoin, the biggest maths festival in the world.
Just to say, Andrew is claiming he's going to have the biggest maths week in the world this week, but it's only day one. So we've had over 400,000 people ourselves. So, what, 3 weeks ago. So, you've a few days left to try and beat us, Andrew, and the very best of luck to you. It's great to see everyone around the world, doing great things to make maths and science accessible to people. I just like to say it's Science Week for us this week. We have Caroline over on Zoom through the wonders of technology, being able to do lots of stuff with groups in Ireland this week for us, and we're delighted with that. As in a few weeks ago, we had Andrew over by Zoom. So the technology, as Tony said, it's one of the good things that's come out of Zoom. It's also the fact that Zoom has showed us that, out of the pandemic, the pandemic has shown us, it has been terrible tragedy and hardship, but it has shown us that the world can come together and act together. And we're going to need that going forward with climate change and other issues. So we need to build on that.
Can I ask you, Eoin, are you planning to use both platforms in future? Are you planning to do the Zoom as well?
Yes, we are planning to go ahead in person and online in future. We have a lot of resources developed ourselves, and we're very happy to share them with you guys. A lot of accessible materials, things. What I would just like to say, what came across to me mostly from this Happy Maths Hour, is the amazement. We have to make sure as teachers and communicators that we're not presenting things as matter of fact. This is, what we've seen today is amazing. This amazing pattern. Wonderful, that it happens. First of all, it's Fibonacci, the sequence itself, the numbers that everyone can understand. And then that relates to this story of rabbits. And in fact, that is a very, very early form of mathematical modeling of population growth. And that is very closely linked to how we model how COVID is transmitting. But then we take it and we look at the ratio of them, and you showed us that there's this amazing relationship, this golden ratio. And we've seen that how often this crops up in nature. All of that is amazing, and we must make sure, and lots of maths. Some maths is we just knuckle down and we practice it, but so much of it is amazing, and we must remember to keep the wonder in maths.
The awe and wonder, and
not presented as, oh, of course, this is how it is. You know,
Uh,
there's
and
no
I- I
reason
ju-
why nature follows this mathematical language. You know, we don't know why. It's amazing. Everything about maths is amazing.
But I'd
And
also like to add that with good teaching, the young people would discover these ideas themselves.
absolutely.
So
And own them.
the sheep talk would be a whole lesson, and the young learners would be discovering the Fibonacci sequence. The
Yeah.
teacher wouldn't explain it like I did this afternoon. And similarly with the rabbits. And there's a lot of mathematical thinking involved. And then they will capture the awe of it, how amazing it is, because and they'll be excited because they've discovered it for themselves.
Yeah. Brilliant work.
And
Thank
then
you.
this week, Southeast Science Festival is happening, and there's lots of events, not just me, and the link's down there, and it's in the description, calmast.ie/events. You can sign up and attend the events. There's lots of
All are free, yeah.
lovely, really lovely activities going on.
And lots
Thank
of
you so much,
things for
Eoin.
adults in the evening, Caroline, as well.
Oh, yes, of course, that's
people-
part of Maths Week Ireland as well. They do the same thing. There's great activities in the evening for adults, yes. Is there anything else you want to mention there, Eoin, about
No, I
the
just say-
Southeast Science Festival?
No, the events are all on the web. There are evening events. We're happy for people to book in to events. As I say, there's evening events for adults, and we'd be very happy to see anyone there. And to finish up, I'd like to thank yourself and Tony, Caroline, for all the great work that you do.
Well,
Thank
we love
you.
doing it, so it's not work. Andrew, would you like to talk about Maths Week England?
I would. but
I thought
actually,
you might.
yeah, I would. I could talk about little else, but actually, let me echo what Eoin said. It's great to hang out with people who have this vision and who share this belief that everybody can do mathematics. I think there's someone said on Facebook recently, just this week, so what's everyone doing for Maths Week England? And one person went, I'm just going to be teaching maths like normal. And I mean, he was, being funny, but actually he's got a point. And, if that is the most important thing we can do, we owe it to our children to teach them well. But that doesn't negate the fact that we can also show them there are things beyond needing to pass exams. People throw statistics at us all the time. As Eoin said, COVID modeling, it's such an important thing. I think, can I share a 50 or 1 minute video? Is that possible, rather than just, because I'll forget?
Yes.
Am I
Yes.
am I allowed to share?
I think so. See, just if you got the share
Well, video
button.
file. It just says video file. That's very exciting. I was going to share a screen. Okay.
Yeah,
Right,
I think you can.
shall I
Yeah,
try
you just go ahead and do the file. Yeah, go for it.
Okay.
We-
It's just, of course, just disappeared just as I did that. Maybe I should just share a screen. That might be a bit easier because
As long as we can hear it.
Yeah, well, that's it. Will you be able to? I don't know. Let's try this. Screen sharing is easiest. Okay, I'll just screen share. Lets you share
Work out
audio.
how to.
It says follow these steps. So this could be good. I could follow some steps.
Yeah, I think it's gonna.
Oh, share screen.
Oh,
There we go.
yeah.
Okay. Chrome tab. Oh no, I don't know what. I think maybe I won't. I think maybe that might just be. There might just be.
Tony, we can't see it. We can
Tempting
see
fate,
your
I'll just-
belly. Look into your belly.
No,
button.
no, I was just, I know you were. I was just looking to the bottom of the
something-
screen so
what's
I could
happening?
say something to help Andrew, because I couldn't see
Okay.
the.
Does it work? Can you see it?
Yeah.
Hold on,
Okay.
hold
Came
on,
up
hold
there.
on. Add to stream. Hold on. It keeps jumping
Oh,
on.
there we go.
Okay.
Okay. All right, let's try this. I don't know if the audio will work. Hold on. Working?
Yes. Yes.
Okay. This is quicker than me waffling on for hours. Everybody was free to follow their dreams, unencumbered by a lack of qualifications or confidence in their own ability. Imagine, too, a world where every single young person in our nation leaves school not only with a qualification in mathematics, but also an understanding and appreciation of its joy, its beauty, and its structures. Imagine too a world where mathematical competence was seen as desirable, a good thing, and not only that, but attainable by everybody. You know what? We can imagine that world, because that is our dream and that is our goal. So thank you so much for joining us, and welcome to Maths Week England.
Excellent.
Outstanding in his own field.
Oh, fantastic. Okay, so can you send me that, Andrew, so I don't know how I'd share it, but I'll find a way to share that. Tell you how to share it. So
yeah, I will. Let me just turn it down. Yeah, yeah, it's on it's on pretty much all our social media channels and the front page of the Maths Week England website as well.
Okay, right.
And it was just, yeah, I just wanted to remind people why we're doing this, really. And it looks like, you know, we're all very much of a mind here. I don't believe there's anybody who can't do it. I really don't.
But I'm glad that you're inviting adults and not just maths teachers, because a lot of adults are parents and grandparents and aunts and uncles. And the worst thing they can do is to say to their children, or in their children's hearing, I never could do mathematics. So we have a big job on our it's going to be harder. We have a big job on our hands, and that is to convert the general population to believe that maths is wonderful. And that if, you know, I'm 100% with Andrew. Everybody can get a good qualification on leaving school in mathematics, and there's nobody who can't do it. But the worst thing is that children lack confidence in their own maths, and so often parents say, well, never mind, I could never do maths either, and it's the worst thing they can say. Mm-hmm. So let's encourage the grown-ups to enjoy maths as well. Let's make it enjoyable for them, and make them aware of how important it is, because it's so important in our world, isn't it? As Eoin was saying, and that's why we do what we do in Africa, to help those kids to escape poverty. Because with a good education, they have a better chance of a job and a better life.
And if you can stay on, Andrew, just for a couple of minutes after we finish, Tony would like to talk to you about that, because you asked me about that once upon a time. So I'd like to, thank you. So we'd like to, we'd love to be part, now that we're doing this every single Monday, I suppose our podcast, we'd love to be part of Maths Week Ireland, of science, whatever events are happening. So we're going to see if we can be part of Maths Week Scotland next year as well. Just extend the invitation. And thank you so much for joining us. Everybody we've got the Maths Week England there. I'm going to put, this is Andrew Jeffrey, whoopsie, not the wrong one. This is, no, sorry. This is Andrew. We haven't spoken about, Eoin does amazing presentations with Calmast. He goes out, you can actually ask Calmast in your organization to come out and do talks and things. I know you do talks all over the place. You worked far too hard. And Andrew, I'm just putting his contact information here. He does professional development. He's a mathematician. What do you call him? The magic message. He is very entertaining, very entertaining. If he's got any spare space in his booking schedule, he is the most amazing. He's absolutely riveting to watch him. He comes up with some great ideas as well. So thank you all. Thank you, Tony, for all the work you put into it. Thank you both for coming. All the best for Southeast Science Festival Ireland and Maths Week England. And see you next time.
Bye, everyone.
Thank you. Bye-bye.
Thank you.